David is going to talk to us about drones and anti-drone countermeasures beyond just simply handing me a drone remote, because I got a drone and the only thing I can do apparently is fly the thing into my face. And I've done that a number of times. So let's give David a big round of applause. Good luck.
Thank you.
Have a good time.
Thank you. Thank you. Well, I can say that I'm pretty irate. So let's get started. Well, welcome to my talk. Glad to see you here. And I'm going to present the project Interceptor. It's about owning anti-drone system with nanodrones. So that's me. Well, I'm David Melendez. I'm a research and development embedded software engineer in a company in Spain. And I the creator, the actor of the several robots, and I'm going to explain later. And the author of the book Hacking con Drones. It's in Spain, in Spanish. And a resident speaker, but not here. And a trainiac. Why I'm saying that I'm a trainiac? This is the Alta Velocidad Español. It's a pretty cool train. It's fast and it's cool, and you go fast. But I'm pretty fan of your trains because they are pretty badass. They stack containers. And big fan of you guys, big fan of you folks. Absolutely. So if you meet later with me, be careful, because maybe I start talking with trains and I can stop. So be careful. So I would like to start with this. Yeah, you're laughing. Good job, folk. I'm thinking about this guy arriving at home and, honey, I'm doing a pretty good job today. So that's one point. The second point, previously in DEF CON, I want to start with drones in DEF CON. And I think that what is the first drone seen in DEF CON, with pretty cool stuff. And well, with hacking capabilities, you can take the drone along the city, taking a lot of networks, and make some cool stuff, right? And the second one was the year ago for the danger drone, and it is a pretty cool stuff because we were use 3G and 4G communication and telemetry. So that's because several anti-drone systems works indeed with 3G and 4G systems, and if you use the same system, the anti-drones, they can be troll you. There's no way to jam your drone. But only because it's illegal to jam 3G, 4G frequencies, it has some kind of problems. So I want to explain drones as a threat. I like that picture because it's pretty cool. Well, we can start talking about drones as a flying computers. It's like Internet of Things over your head. IoT is, we can call IoT as before we turn to assholes because there were named quadcopters. Okay, they can use custom payloads, sniffer, jammers, network analyzers, 3D mapping cameras, and so on. Some kind of cool stuff you can put in your drone. So any kind of thing you can imagine, you can put in your drone. A drone is a vehicle. It's not a weapon. It's a tool. All right. So how we can detect drones? Well, the first one is, okay, I'm seeing a drone. Okay, I detected it. So there are thermal and standard cameras. Well, nowadays there are a lot of systems that they are able to detect drones by its shape and with artificial intelligence and so on, and with thermal cameras with electronics and motor heat detection. Okay, you see 4 dots on the sky that are pretty hot. It's not a pigeon, I think. Also, other detection method is characterization of drone noise. A pigeon doesn't sound. Okay, we got it. Detecting radio frequency and waveform. This is the most important method to detect drones, because every drone has a signature of radio communication, and it's pretty easy to detect those drones, because, for example, and Wi-Fi with the access point name put here a manufactured drone. It must be a drone. Okay. Well, other methods to detect drones. I'm a pretty fan of this. Voluntary measures. Well, if you install in your drone an application that reports to cops that you are flying a drone in a certain area and at a certain time, okay, no problem at all. Everything will be all right, right? So this application gives to cops the ability to take down your drone. Imagine if you install this application on your car. Okay, everything will be all right. So, perfect plan. So, how about the counter measures? Well, we can use several methods that they are already on the stage, like split the spectrum. That you can transmit in a very wide area of radio frequency, and with the hope that nobody can jump on all the area. Frequency hopping, you can hop to many channels and use respective frequencies, but the jammer expects that the drones works in a certain frequencies, and robust protocols that we are talking about this. Well, I'm going to explain my first round of this stuff. That it is called Atropos. It's a quadcopter that I built like 6 years ago. You can Google it. It's in Hackaday and so on. And I decided to build with a Wi-Fi router. It's a Wi-Fi router and La Fonera router. And well, some cool stuff like Wii Remote of Nintendo as inertial sensors. So 6 years ago, there's no Chinese manufacturers that you can buy and they take your sensor to your home. So there was easier to take the sensor from the Wii Nunchaku. And I decided to put the sensors to the router directly by attaching the bus to the lights, okay, and control it by a web server installed on the router. The program, the stabilization program is programmed in C inside the router, and it has an embedded system, and also has another capability with Bully that is able to attack other Wi-Fis. So you can see the La Fonera router and some pretty cool and professional soldering skills, and that's perfect. So now what else? I like to see this movie because, well, all the other Star Wars movies make me cry, so I like this one. Okay, and I like particularly a scene that we count 30 rebel ships, Lord Vader, but there is so small they're evading our turbolazers. That gives me an idea, and why not make a small drone, okay, with chopsticks? Okay, because people ask me, why are you using chopsticks? Don't you have a 3D printer or somewhere? Are you poor or what? Well, if I print the drone, nobody believes me it's mine. So this is mine. I'm going to check that actually the drone is draining its battery, so maybe I have to fly before the battery drains. Okay, all right. So the Boreal Interceptor is based on low budget. No, seriously, low. You take a cheap sensor, a cheap board, and a cheap everything. Minimum size and weight, harder to detect, okay? And with all stuff that is on this thing, no? Hacking capabilities and resilient control. Well, this is the drone and the chopsticks. We can see a Linux board inside that is indeed a router with OpenWRT Linux distribution inside, and some cool stuff like brushed motors. Why brushed? Because they are cheap, ridiculously cheap, okay, and small. So we have transistors and SDR and a camera, so on. So you can compare with a €1 coin, okay. And this is the V-Core 2. I think this is the smallest board on the market. That is run Linux, and we have Wi-Fi, and yeah, that's the specifications, and we have a one core of CPU, and 3 serial ports, and the most important thing is PWM ports. And there is 4. There are 4 ports of pulse width modulation. Okay. Those ports are used to control the motors without any other integrated circuit, just because it has to be small, it has to be cheap, and we have to take advantage on all the hardware stuff. Okay. So we need 4 PWM signals to control the motors, 1 for each one, and they are hard real-time constrained. We cannot emulate, or it's very difficult and uncomfortable to emulate those signals with the quality required to make the drone works. So we have 4 channels available, but we only 2 enable by the manufacturer. We have to enable the other one. But what happens when the other 2? They are the serial debug console. Good job, right? Okay. So we have to disable the serial port for debugging and enable all the 4 pins. I went to the forum. The guy that designed the V-Core is answering questions, and one guy asked to enable these pins, and the guy answered, "Well, it's a hard way. Well, you have to download the Linux source from V-Core. Second find the DTS, insert, try to understand the pin control, and you have to understand some kind of stuff, and then you make magic, okay? And you will be a good Linux hacker, okay? What the fuck? Thank you for nothing, guy. So here you have all the stuff that you need to enable and disable all the stuff. You have the UART pins defined. You have a pin max. Okay, this is a maxer, interconnected inside of the system on chip. You have to wire functions with outputs, because chip has more functions than outputs, and you assign a function to an output. So you have to reassign, disable the UART, and enable the power width modulation. We have to redefine those pins. I call PWM pins. We have the first one, the 0, the 1, that they are already defined, but I'm going to define the other 2. That is called UART2 PWM. The group is UART, but the function is PWM. Additionally, in the I2C bus, I attach a sensor to take into account the battery. Okay, we disable UART and we enable the 4 channels. Well, this is only for your information from the datasheet, where I found the information to change that. Well, the power stage is a MOSFET. That's me in my work pretending to know what I'm doing with an oscilloscope, and there is my personal version of an electronic speed controller. Okay, this is the oscilloscope, because with brushed motors we have to deal with counter electromotive force, because when the motor is spinning, I have to power it, but the motor acts also as a generator and puts current in the circuit, a reverse current. So I have to cancel it with a capacitor and a diode and Schottky diode. This is the PED tuning. This is the worst part of build a drone. You have to tune it from 0, 0, 0. Okay. And well, I'm going to explain the Wi-Fi architecture of this drone. That is not a Wi-Fi regular drone, because it works as a beacon frame based communication. That's because if you are not authenticated to any network, you cannot be deauthenticated. Okay, nobody come here to the authentication attack and deauthenticate my drone, because it's not authenticated to anything. We have a joystick. The joystick is not a fancy RC drone remote. That one. And we have a pilot side, that this is my laptop, with an additional Wi-Fi adapter. So my communication protocol is based on beacon frames. So in the payload of those beacon frames travel all the data from my remote, from my joystick, and to the pilot, and reverse. If you turn on your laptops or mobiles, you will see two networks, one called Interceptor and the other one called Piloto or Pilot. There are fake networks, okay? One network is generated by my laptop and the other network is generated by the drone. Both sides are designed to listen to each other and well, for control and telemetry, as you can see that on that slide, protected with an encryption algorithm, because if not, we are not doing nothing. So this is the packet format, and you can see all the stuff of encryption algorithm. We have an initialization vector, we have a command, a sequence number, and an integrity check. So there is, this is the, they travel inside the beacon frame. So I would like we can turn on the drone. I will put on the ground for my safety, not for yours. Maybe I'm going to change the battery later. I have to change the battery. I will try here. I bring another battery. Well, while it starts again, I'm going to explain you a particular characteristic of this protocol, but because it's allowed me to change the channels of the Wi-Fi of both Wi-Fis, the drone and the pilot, while I'm flying it without losing control. That because the Wi-Fi adapters they are not perfect. So if you are on channel 1, you are listening packets from channel 2, for example. This protocol takes advantage of this, because if I want to change the channel of the drone from channel 1 to channel 5, I tell the drone, change to channel 2, okay? The drone acknowledges that, okay, I'm channel 2, change your change to channel 2. So both pilot and drone are in the channel 2. So they are in a loop, changing channels, each other, until they reach all the to the channel 5 or the target channel that I set. This is the interface. Well, there's some common stuff of this web interface the interface is created on the laptop. The laptop receives the beacon frames. They turn into WebSocket packets, and it's they see on the web page. So I want to show you a video. This is the interface and the drone, and there are the networks on my house. The drone keeps auditing the networks, but I can control the drone while the drone is attacking the networks with bully. Okay, so there is so many networks on the air, and I am changing the channel of the drone. Well, you see, they each other are negotiating the change of the channel. You can see that here channel 8, both, okay, and they change seamlessly. Okay, I don't lose the control. That because I don't want to put an extra adapter, an extra Wi-Fi adapter on the drone. Okay, because it's very expensive. It's an extra weight to the drone, especially. Okay. Are you safe? Well, it's almost okay. Okay. So I'm not a very professional pilot, indeed, but well, the other investigation that I'm doing with this is to prove that anybody is able to build a drone with a custom flight controller like mine. This is all programmed on C, both the stabilization program inside the V core and the protocol of communication. It has I'm working right now on an extra fallback communication system based on SDR. Okay, just in case a drone jammer detect my network, because my network you can see as a pilot or as an interceptor, but they can change to be the same as the nearby networks. Okay, that is to hide the presence of the drone. So another protocol is a fallback protocol based on FM that it selects an arbitrary frequency inside that range and start transmitting if the pilot detects that no more telemetry comes from the drone, that the link is broken. So it transmits with an arbitrary frequency, and the leitmotif of this project is that transmitting illegal frequencies are the less problem for bad guys. If you are to do bad things, the less of your problem is to transmit on FM. Okay. So this is a warning to drone manufacturers, because I still keep sending commands to the drone even without Wi-Fi, using a Raspberry Pi radio transmission with RPTX project, okay, as a proof of concept. So I'm selecting the frequency dynamically. So we survey the spectrum, and I detect the peaks and the valleys, and then I select the best suitable frequency. So the fallback FM-based communication, we have the joystick. They are limited to 4 bytes packet, and they are transmitted to FSK modulation using the mini modem project, and they turn into RF format. Okay, they are FM modulated transmission, and they are on air by Raspberry Pi. So an SDR dongle on drone captures that frequency and makes the reverse path. Okay, we have an audio capture, and we have to demodulate that packet with the same mini modem, but compiled with for the architecture of the drone, this MIPS. And we have the 4-byte format for flight control. Okay, that was the demo. You can see I'm like Porkins. Okay, I would like to explain more. We have more time. I would like to explain a little bit more what method I follow to pit tuning, because it's the hardest part to make a drone. I attach to a 6A bench, professional grade, with also chopsticks, okay, and other home parts on the you can see. So you have to tune the P, that is the proportional gain. It's you send we stay here. If the drone stays here, and I want to stay straight, the error is 0. If it moves, the error changes. So we have to multiply the error by the proportional gain. Okay, we have one force. The second force is the integral term. So I have to take into account how much time is the drone in an error stage. Okay, and the derivative term is, it takes into account the speed that I'm reaching the desired position. Okay, that those values multiply with a gain, we have a real control of the drone. Okay. So okay. This is my paper. Okay, I would like to see you. So as conclusions, I would like to show you the conclusions. Okay, we have a ridiculous small size, weight and cost. This brings to the next point. Hardware hacking from scratch. Even you can track, if you buy a router, can track that you are building a drone for bad or for good. Okay, so we have a side hidden channels communication as a central philosophy, no vendor or 3D 4G communications. We keep the cost low because we are using Wi-Fi also, but we have professional capabilities to keep the communication safe, or as safe as we can. If an unexpected attack is performed, or all the Wi-Fi spectrum is jammed, we have a fallback system to keep the drone control, and we have people can steal us. We also have hacking capabilities to hack another Wi-Fi networks, pen testing, and so on, keeping on only one adapter on the drone. Okay, with the same adapter, we have travel throughout all the Wi-Fi channels. So, and a firewall control based on SDR protocol. So, I would like to thank you to stay here, and well, if you have any questions, so thank you very much.